Start recording. So let us just begin with the problem by it. Okay. So this was, let's call this as problem number 1. Let's do this. Were you able to do it completely? Okay. Then there's something that we can do then. Yeah, so it was not very easy, but since you had got the concept, so then I just gave a little tricky question. Let's see. So we had this parallelogram to begin with, and then there was this arbitrary triangle, or rather arbitrary star made out of point like this. And that's before labeling point. So we had this region outside the star. Is this figure okay? This was the figure. Is that right? Yeah. Okay. So we had this region which is outside the star. And then there is a region which is inside the pentagon that is formed. So maybe blue. And we want to say that the difference doesn't depend on the star. So let's first label all the points. Then you can tell me what you have tried. P, Q, R. So yeah, red. So when I put a box, you understand I just mean area. Red minus blue. This is a I'll just say is a constant. It doesn't depend on the points P, Q, R. Constant. Okay. Yeah. So you can tell me what you have tried. Right? That will be good to begin with. Sorry, yeah, DAP you said. Yeah. That's right, yeah. Okay. So let me note that. Mm-hmm. Yeah, just give me a minute. You say?
And yesterday, I mean last class,
Mm-hmm.
also told me how we can do. So we can add ZY.
Should I label the star pentagon? Yeah, right. I should enable that. Then it will be easier. X, Y. Okay.
So to get the triangle DAP, last class you told me to add RYZ
Mm-hmm.
DAP.
To DAP or okay, no. So let me say the idea instead, right? That will be better because it's not the exact thing. Yeah. See, the thing is, the red region is not such a good region. It's not such a complete cutout region, right? We want to get a good region, right? And that's why to the red region, we want to add RYZ. You see, that way you get a good region. And also you need to add a W. Okay, I didn't label this point. let's call it U, right? WUQ. So to the red region, you want to add RYZ and this other triangle WUQ, because together they will make this good region, DAP plus PBC. Okay. So then with that, using that, what can you say? Hi, Unhab. We are just basically, I think you have already done this problem, but we're doing this again because I think this was a little tricky. So you can just see and you can tell us some ideas also along the way. Okay.
Set triangles in the to the red area.
Okay. So then to the red area, we are adding this RYZ plus WUQ. Okay, so this is more complete. This is half of ABCD. Yeah. Yeah. Hi, Ishana. We are just doing this problem which we have already done, but maybe you can help us along the way. Okay, quickly. Then we'll go to a new problem. Yeah. I think you guys were joining late, so I just did this problem. Anyways. Yeah.
That was all I got to, and then I couldn't continue.
Okay. Okay. Right. So you have turned, so I mean, everybody here, we have turned the red region. From the red region, we have kind of added the missing pieces to the red region to get a good region, right? That is DAP plus PBC. All of you agree? Right? Now, what should we do now? Like we have to do something similar to the blue region maybe, but or what? Like what should we do? So I'm not saying it because the idea is similar. So please think about it, all of you, and then you can say. That's the kind of the theme, add the missing pieces. So I just put it there. It is some old Soviet problem. I've taken it from a book called Which Way Did the Bicycle Go? You can look that book. It has some very wonderful problems. Yeah. So we want to show that this red region minus the blue region is a constant. We have added something to the red region. Now to the blue region also we should add something, right? Like, so suppose if you want to show that this red minus blue is, let's say, 10, but you have added these things to the red region, and obviously you should add them to the blue region also. Otherwise it doesn't make sense. Or just look at the blue region. It's a pentagon, right? It's not such a good, I mean, it's a good shape, but it's not such an easy shape to understand. So what should you add to that pentagon to get a good shape, to get a more easy to understand shape? Triangles. Yeah, that's what it is. Exactly. Which two triangles you can say? or anyone?
It can be any of those three. PZW to XCC or XDY.
See, if you only add PZW, only adding PZW is not good enough, right? Because then, right. So, but even if you add like PZW plus this, then also it's not such a good shape, right? It's a very weird shape. So in fact, there are two precise triangles which you have to add. Come on, Unab, can you tell which triangles should we add? Okay, maybe you got cut out in the middle. Okay. Come on, someone tell me. Yes, yes. So my question is to all of you is to RW, UX, Z, this thing, we need to add something to this region. This is not such a good region, this pentagon. We need to add something to it to get a complete region, to get a good region. What should that be? So already we understand there should be two triangles that we want to add. Which two triangles should we add? To make it half, right? I'm not sure about half, but to make it a good shape, to make it a triangle, just to make it a triangle. Well, yeah, that is certainly an option. So let's try that. Yeah, I think Pragadish, you were also saying something similar. Maybe I didn't understand you that time. Yeah.
Yeah,
Ah.
I wasn't sure whether to add because that's another option. PZW and DYX.
Yeah, that's also an option. Yeah. So let's see which one works, or let's see if any one of them will work or not. Let's see. So then we are going to add PZW. And okay, so then what happens? We get YPC. We get YPC. What do we do next? By the way, this is the blue region. So just to recap, to the red region, we had added these two things and we got something very nice, very good shape, very good numerically also. And now to blue region, we have added two other things. Is this nice? Can we say anything about YPC or something like that? Let's see. So this we have geometrically motivated ourselves, right, to get a good shape. Okay, so we have guided ourselves with the geometry, with the shape, and we have said this. I mean, the other option is kind of equally obvious, equally maybe likely to work or not likely to work. There is a third option also. Let's see. This is a tricky problem, little tricky, not very tricky, I should say. Is this any good? Let's think clearly. Is YPC any good? Can we make it? Can we use it?
No, I don't think so.
Okay. Yeah, so it doesn't look very good. So then it means that this the other choice, which was PZW and DYX, that is also not so good because that's also similar. Or I don't know. So you can think. Yeah, so then what should we do? What is the other choice? So you want to make the pentagon into a triangle. Think maybe specifically like this. How do you make this pentagon into a triangle? There are two ways which they don't seem to work. What's the other way? There is one more way. Yes, right. And that is actually the most natural thing to add, right? Even if you guide yourself algebraically, right? Because that's what we had here, R by Z and WQ. Okay. So maybe it was worth doing this problem. I mean, maybe I can say second time, but it's fine. It's not really, it's good then. Okay. RYZ and WQ. So then what do we get? But yeah, maybe this doesn't initially look like it's going to be it's going to be any better, but let's see. Okay. RX, we get RXQ. Okay, let's see. Now it will, because something special. Say, with RXQ is kind of very much related to DXC. So one more thing, I have written something wrong here. Let me correct that. So just please see here once. So we had this red region, right? Okay, well, not really. Yeah, it's wrong. Yeah, we had this red region. And then if you add RYZ and you add WQ, then what do you get? You don't just get DAP plus BBC, you also get this DXC, which I have not written. So it's wrong. It's incomplete, right? So I will also have to add this thing. So I'm sorry, maybe that made the problem like we couldn't see the idea directly, maybe because I didn't write it. So we have this DXC also, which I missed. Do you guys see that I missed it? I had missed it. Yes. No, it was in the red part. But after adding RYZ and WQ to the red part, you don't get you don't only get half the parallelogram. You get this DXC extra, right? So then you see it, right? Okay. So see, initially we had to show that this red minus blue is a constant, but now we have kind of added some pieces. So naturally, now we would like to show that this, okay, let's call this L, and this, let's call this M. We want to now show that L minus M is a constant. I mean, this is the same problem. And that's why we added these pieces, right? So we have added the same thing to both the quantities, right? So the difference doesn't really change. And now we want to show that this is a constant. L minus M is a constant. first see if this is making sense or not, because this maybe is a slightly new idea. Okay. Pragadish, is it okay with you also? Because maybe this is the first time, maybe if you've seen this idea. Okay, right. So then, and this is really why we added the pieces, right? Just okay. So now how do you show that L minus M is a constant? So L, I'm just going to write it. I'm not going to say the answer. L is this. It's writing it here in one place. And Rx cube. We want to show that this is a constant. Yeah. So naturally we can just just focus on this thing, because I mean the other thing is obviously already a constant. So we don't have to really focus on ABCD and half of that. We can forget that. We can just focus on DXC and RXQ. So it boils down to show now you can use your imagination. You can try to move the points R or Q or whatever and try to see what is happening. What's the relation between those two triangles, their areas. Yes, they both have the, okay, they both have the same height. Okay, so then let me not say the rest of the thing. So complete this on your own. I think already one hint has been given. Complete it. Is it okay? Try to complete this, because already a hint has been given that they have the same height, because obviously they are between the same parallels AD and A and BC. So they have the same height. Try to complete it. If you cannot do it, then ask me on WhatsApp or whatever, or next class also you can ask me. Okay. Yeah, by the way, when I give these problems, you can always ask me for hints in between. I mean, the days when we don't have class, if I can, I'll try to help. Okay. So that you can progress more. So let us move to a new problem. So how do you guys find these problems? If you, yeah, then that's good, right? So it's good, and also it's a little unorthodox. So it means you don't get the practice of these kind of problems maybe in the books usually. So it's a little new kind of thing, but these are Olympiadish and also, and obviously as Ishana said, it's a good kind of thinking, imagination. So basically, just thinking about symmetry and what is symmetry and what is symmetrical. Good idea without too many calculations and too much math, like actual. Okay. So I had given other kinds of problems, um, but let me not do them. Let me do one problem which I have a type of which I have done earlier with Ishana and Unhab, but all of us will try to do this now. Okay, let's see. So this has a slightly different flavor. This is some old PRMO, sorry, not PRMO, RMO question. Okay, so let's call this problem number 2. This has a slightly different flavor. And I will discuss the leftover problems soon, but let's do this one. This is, I don't remember the year, but this is a RMO question. This is like this. And so this is the midpoint. And from here, we are taking 1/3. So don't worry if you have never done these kind of problems, then you may not be able to get started even, but don't worry about that. Okay, you will we all be able to do it soon. And let's see what ideas come. So you can see what I'm trying to do, right? I'm trying to trisect this side. Sorry. So this is A, B. This table is a little low. So you can already start thinking about this. I am asking for the area of this piece. Or let me not ask for that piece first. Let's ask for this piece. This is slightly easier maybe. I'll write down the details, but you guys can start thinking already. This is D is the midpoint and E and F are the points of trisection. ABC is just an arbitrary triangle. Nothing is given. Obviously, what I want you to find out is green by the full thing. Yeah, this. Okay. Yeah, that's all. So we want to see the interplay of areas and ratios. Okay, you already would have seen some basic things about this thing, and yeah, soon these ideas will be used to prove actual theorems. Shiva's theorem, Menelau's theorem, you may have heard. Any ideas? So first of all, do you see something really unnecessary that I have given in the question? There is something really unnecessary that is present in the question. I mean, the line BF, right? The line BF is completely unnecessary for this question, right? So why keep it maybe, right? So don't focus on it basically, right? It's not important for now, for this problem. And so remember AF is basically AE, sorry, 2 times EC. Now it looks like such a simple problem. Okay, I mean, simple to state. So what could be the ways to go about this kind of problem? Then we'll do the harder version after this, maybe. Right. Yeah, ABD is half of ABC. So you guys see that, right? That's the first step, maybe.
Why is ABD half of ABC?
Yes, because see, D is the midpoint. Try to use that. D is the midpoint. Yep. So the situation is like this. If I isolate it, then it's easy to see. So it has half the base of ABC. Right? At the same height as ABC. So this is the idea, okay, that when the heights are same, then the ratio of the bases determine the ratio of the areas. This idea will be used repeatedly. It's a very simple idea. We'll use this repeatedly time and again. The ratio of the bases basically will give you the ratio of the areas because the heights are the same. So now basically we are inside ABD, and now we basically want to find the green region by ABD, right? Want to find. So I'm just kind of guiding you as to how you should think. That's all. Okay. The green region by ABD. There could be other ways. Mm-hmm.
Is BEC half of the triangle too?
BEC, is it? So you can try to calculate. Let's see. So what is so maybe anyone can try this. BEC by ABC. What is this? So all you need to look at is this ratio of these bases first. That's all, right? That will, yeah, Unab? Yes. So it's not, so then, right. So what does that give us? So that will give, maybe I should write like this, BEA. So what is this? This is half, right? And so then you can just do your calculations and you will get that BEC is actually 1/3, right? Is 1/3 of ABC. And you can just calculate that. Basically, EC is 1/3 of AC, so it's 1/3. Okay, okay, Unap, is that okay? Just the ratio of the bases, right? EC is 1/3 of the whole base. So its area is also 1/3 of the whole thing. If you ask compared to the whole thing of ABC. Okay, so that's us on the same lines. So let me keep this. Let's remove this. Sorry. Are sooner or later we will look at some theorems which will help you to do this problem like in one line. So just remember, yeah. But these problems precede that theorem. Then you get the intuition hang of that theorem also. Otherwise, obviously, just for using, I can tell you the theorem, but so we're doing this without theorem. Otherwise, it's easier. So we want the ratio of the green region by ABD. That's one way to put it. I mean, you could also go by green region by maybe BEC. You could go by that also, but that is similar maybe, and it looks a little harder. Okay, because so we'll go with this only, the green region by ABD. So this is the question about areas, but what ratio of lengths is this equal to? This ratio, the green region by ABD, so how could we turn this into a problem about ratio of lengths of a line basis? So look at look at BGD and look at ABD. They have the same base. I mean, they have the same, not the same baseline segment, but the same baseline, the same platform. So how can you use that? Mm-hmm. Yes.
BGD be half of the whole thing, and then you can say maybe relate ABD equal to half into ABC.
Yes, but BGD is half of what? No, but how do you know it's half of the BEC? No. Yes, but it's the midpoint. Heights are different. Yeah. If you take this, we have to understand this very clearly. You see, if you take this line DE, then you see it doesn't maybe look like that exactly, but it is true. DEC is equal to BED. You see, because these two triangles have the same baseline, not the same baseline segment, the same baseline, the same platform, and they have the same height because they have a common vertex. So you have to be careful when you apply this theorem, right? If I take a situation like this, then I can say like if this is 2:5, then the area is also 2:5. But then if I if I just take a triangle like this, then I cannot say, right, that this is whatever this and this is 2:5 because they don't have the same height. Okay, so yeah, that's so you have to be careful when you apply this. To be very careful, meaning just go to the basics and see. Okay, base height and so on, and so it becomes, get used to it. So see, so green region by ABD, what ratios do this correspond to? Because we are falling back to the basis, the ratio of lines, right? So this will correspond to GD. Is that right? GD by, tell me the other ratio. AD, right? Do all of you see this? We have not found anything. You're just showing the how these two are the same things. Is that something that all of you see? Okay, Pragdish. Okay, nice. So this is again the same idea we have used in a different way. Now we need to find GD by AD because it doesn't look, I mean, at least to me, it doesn't look like that we can find the areas so directly. So we are going back, we're using the basis. So can we find GD by AD or GD by AG? Either one of them you can then find here. So how do you find GD by AG or GD by AD? So that's the goal now, right? What do you think? Why do you think that is true? Okay. Okay, let's see what others have to say. Yeah, so if he's saying that since AE by EC is 2:1 or some ratio, does it mean that AE AG by GD will also be the same ratio? Not necessarily, right? But it's a right line to look at in some sense, but it's not true. When is it true? When are such things true? Yes, if GE would have been parallel to DC, right? So you take these lines, and then if you have two parallel lines, then only you can say that this ratio, this by this, or whatever, right? I mean, you can make the triangle first. Then only you can say that this by this is same as this by this. Only if they have parallels in between. Okay? If parallels don't traverse it, then you cannot say. Because obviously the ratio is changing. The ratio is constantly changing. Okay, in fact, you can see when you're going down, 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 this is kind of vanishing. GD is kind of vanishing. So, but yeah, maybe you can kind of say that it's more than 2:1, right? Maybe you could use that. Like if there are options and such, you could do that. AG by GD is just, just saying, this is nothing good or bad. It's just what we can do. AG by GD is more than 2. And also I've discussed this earlier, like these kind of questions, if you don't have to do the problem, then you can, maybe you should if it's just an MCQ, and if you know the answer is a number, you can simply take an equilateral triangle and do this problem. Now it's a fantastic thing that this answer doesn't depend on whether the triangle is equilateral or what triangle it is. That's a very fantastic thing, right? That this ratio, just besides the problem, just for a second, okay? This ratio doesn't depend on the nature of the triangle. Just think about this. Like, think about this thing, right? Even if the triangle is not given, or the triangle's angles could change, still this ratio does not change. Try to think about why this is happening. And it's not about finding the answer and then saying, no. Like if I could give you hundreds of lines like this, and I would tell you all the ratios, then also if I ask you for a small triangle, it's fantastic that its ratio with respect to the bigger triangle, or the bigger triangle's area is 1, then its area is completely fixed. Or, same thing. Try to think why this is true. Why this doesn't depend on the nature of the triangle. That's something that you can think. But yeah, but that means you can exploit it definitely. That you can just take an equilateral triangle, and then things are very easy to calculate. You can understand, you can use all sorts of measurements and all that, Pythagoras theorem or whatnot. Or if you know trigonometry, you can use that. Okay, for finding the answer, but obviously we are interested in the actual process, because yeah, that's what it is. Okay, so how do you find GD by AD? So the idea is that, as Pragadish kind of, it's to compare it with AE by EC somehow, or compare it, kind of go to the line AC somehow to understand its ratio. I'll just drink some water. Okay, so let's see. And here also we learn a new technique, and there are I'll give some problems related to that later, but first let's see what it is. It could be other ways. So if you want to project the ratio AG by GD onto the triangle AC. So as we already saw that we would like through our mistake is that we should draw this parallel line, right? Because this parallel line helps us. Can anybody tell why it will be helpful, or be even better how? I'm just drawing this here and leaving it. Now you guys tell me the motivation. DFC is equal to BGD. No? Why? Okay, you're saying the area is equal. Yes, okay, that's right. The area is equal, right? Right. But that's a good observation. I didn't see that. Right. Okay, yeah. So that's certainly true. So let's note that. So we have, this was not what I was thinking, but this works, definitely works, right? So try to see what Ishana has pointed out. This is a new idea maybe, is that this is equal to DFC, right? BGD is equal to DFC. The areas is the same. That's a claim. So why is that true, Ishana? Can you tell us? G and F are on the same line. Hmm. Oh, but now it is not the same then, right? Is it same? No, but is it same in this case? No. No. It is not same. Sorry. Yeah, it is not correct. Yeah. It would have been correct if this is a sides point. This would have been correct if GD was parallel to EC. Something like this. Okay, but anyways, that's just gets complicated. Let's not think about that now. It'll work, but not in this way. Yes, sorry, this is not correct. So then what's the point of drawing this line? Well, you see, when you draw this line, right, then this ratio AG by GD gets projected here on this line, right? We get this thing, AG by GD is same as AE by EF. Just see if this makes sense. This is what you call your Thales theorem, I think. But either way, it's just, you can see it. Yeah. So we go to this line, right, where we have the other ratio of AF by FC, which we could try to use, or AE by EC, which we could try to use. Okay. So that's the idea of projecting the ratio. Okay. We project the ratio which we want to find by drawing parallel lines. You could see how I've done it, right? Like we wanted this by this. You already had a line here. Now you want a line parallel to it, right? This, and then when it cuts some other more familiar line like AC is a better line, there you can find it. Yeah. So this is a technique. So now what? Now what do we do? Now it's kind of not very difficult, but let's see. Because AE by EF is in a very familiar place. We know AE by EC. Is F the midpoint of EC? Is it? What do others think? Or if, yeah, I think it is true. Can anybody prove it? Okay, is parallel. What is parallel? DF is parallel to BE. Right. And D is the midpoint here. So do you see, does everybody see this? Like if you just see from here, right? This is the base and you're looking at this triangle, right? And obviously D is the midpoint of BC. And so when you draw a parallel, this will also be midpoint. This is fantastic, right? This is why this is such a cute problem, okay? And in this technique just keeps getting used again and again. That's why. That's another, it's not just a small trick that is just here. Okay? But yeah, does everybody see this? Take your time. If you don't see it, you can ask first or try to understand first. So then I assume everybody sees it. Okay. So then I think it's fine, right? Now it is just calculations, right? So you 1.8. I do not know the answer, but it should be. It should be correct. Yeah. So then have you found the ratio AG by GD? If you can tell that, then it's. Mm-hmm. Yes, yeah. Okay, yeah. From here you can do, yes, and then from there you can, yeah, and then it's right. It's one. So that is a calculation that's simple, but you see this problem has several ideas in it. Okay, it's not just one shot, one hit wonder, right? There are several ideas in it. Okay. Now I'm going to give a slightly challenging problem. Okay, try this. Yes. Maybe Pragadish, can you explain then with step by from there the steps? Okay. Uh, but there is a slight error. There is a computational error in what you have said. So Ishana, is this part clear to you? AE is 4 times EF. Okay, yeah. Now there is a small computational error. Can anybody catch that? Or Pragadish, you can only see it maybe. Just think. No, ABG is not half. What? ABG is not half of ABC. Yeah, you're making the same. No, just think it's a small slight error, which all of you, I'm sure, can fix on your own. But I just want to fix it. We want to fix it now only. Yeah, it's that thing. Okay, and all of you see that? Yeah. So this is like 5 times, right? It's we want to compare it with ABD, not ABG. Finally, we want to compare it with ABD. Okay? That is just bookkeeping, right? If you just keep the steps step by step, you'll not go wrong. I mean, if you go wrong, you can trace it back and correct it. Right? So it's fine. Right? This is like this, and then you can finish it. So that's just calculations. Okay. So yeah. So I see that these problems are not very easy, even for I think Vishana and Una, which we kind of already we did this kind of problem earlier, but it's all we only did one of them. So it's yeah. Right. So now let me give some problems for you to try. Yeah. Certainly there is this one. This is which I initially intended to do. So you can note it down, or you can see it later, but note it down. Maybe. This is what I want to do. F. Okay. And they are all equal. So you can see this. Okay, just the red part. And this time, so you see this now, the idea is similar, but then you could make this problem very long, or if you can do it nicely, it will be smaller. But first try to do it. Let's see if you can do it, because this is not very simple, not straightforward maybe completely. But there is no new idea in this. Okay. So yeah, we want to find this green region by ABC. So I'm not writing the labels, you create your own labels and do. Okay. So yeah, this is the problem. Okay, so note it down. I'll do one more problem before ending, and that will be like a precursor to something very special that is to come later. Oh yes, so I erased that. Yeah. So again, same things. PD is equal to DC, okay, and AF is equal to FE is equal to EC. Okay, so it's a that AC is trisected and BC is bisected. Okay, and you want to find this green regions area with respect to ABC. Okay. So then I'm erasing this. Is the question okay with everyone? Let me do this question, which looks very simple, and it is simple, but it's something big to come. But we won't do that now, do that later. This is the triangle, and we're just drawing a parallel line. Just a parallel line. Okay. And now we just want to basically you don't have a compass. You just want to, with the ruler, do what you can after the parallel line is given to you. Kind of. Okay. So just taking intersections of the points that we have to create new intersections. It's a very fundamental process. Okay. Now I want you to find the ratio that this line bisects the basin, and you can guess it's half, obviously. So we want to basically prove that it is half. So again, remember, EF is parallel to BC. That's all. I'm not telling you whether E is the midpoint or whatnot. You can already see it's not, right? So I'm not telling you that. That is not given. We still want to show that D is the midpoint. And D is, you can understand, D is passing through A and this new intersection, new point. Okay. So we want to show that D is a midpoint. So if you have to find it, if you don't have to prove it, then it's very simple. You can see it's the midpoint. You can take E and F to be the midpoints. Then you know that it will be the midpoint. It's kind of medians and so on, right? You can do work that out. But in general, you want to show that D is a midpoint. So this problem is very fundamental because see, initially I did not even start with any ratios. Okay, I didn't even start with any ratios. I just had one thing, which is these two lines are parallel, which is basically saying that it's meeting at infinity. But and then I had this. I have a ratio suddenly. BD is half of DC. BD is equal to DC, sorry. Which two triangles? ABD and okay. How do you say they have the same area? Okay. E F O. No, but the area is not going to be the same. Not necessarily. No, area is not going to be the same. Just think. It suddenly looks smaller, right? Or am I wrong? Wait, I might be making a mistake. No, the angle is the same, but that's about it, I think. Right, so they're similar triangles. But I don't think we can say about the area. Yeah, even usually the proof that we do, we use a different setup. We say that there is a point at infinity where they meet, and then we use some theorem. But this can be done by a simple method, and that's how it's supposed to be done in high school, or just in the standards you are. So we are interested in the ratio BD by DC. So what I'm thinking, I don't know how to do this, okay? But what I'm thinking is, since we are interested in PD by DC, why don't we just project it on this side? Okay. By the way, are you guys comfortable with this? I'm drawing this parallel line suddenly. Yes, yes. Mm-hmm. Uh-huh. No, 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 no. They have the same base and they have the, so see, what is the base? The base is BD. So if the base is BD, then their height is this one, right? This is the height which I've just drawn, right? This is the height. So the height is same and the base is same. That's all. You cannot say about the other sides. Okay, you cannot say about FB and EB and FC, right? They are not same. You can see if I just make a tilted triangle, they will not be same, right? So area is a very loose quantity. You cannot extrapolate too much from for the sides. So we cannot say unless more and more things are given. Okay. So my question was, are you guys comfortable with this? Like I'm drawing this parallel line, a line parallel to BF, this yellow line. Or is it very strange? That's not strange. Is it fine? Okay. You can see why I'm doing this, right? Just to say it again, is that BD is, we want to study BD by DC. So I'm just means, what can I do? I'm just trying to see that ratio in different places. Okay, that's all I'm doing. Just I have no options, so I'm doing that. Think of it like that. I mean, there are many beautiful ways to do this, but they are a little out of scope for us. So we're trying to do this like this, okay? This is really a problem for which you need a plane in which there is a point at infinity, which we don't have yet, that concept, that language we don't have. Under that language, this problem becomes easier, but we cannot introduce a new language for that. So this is G and this is H. Okay? So at least we can say that BD by DC is equal to FG by GC. Whether this will be useful, I don't know. You have to see. Sorry. Yes, because once again, you can see that BFC is the triangle, right? BFC is a triangle, and DG is a line which is parallel to it. All right, so the ratio carries over, right? is BD by DC, whatever it is, it carries over to FG by GC. Okay, so it's the same thing, but you're seeing it in a slightly tilted way. I mean, from BF as the base. Okay, just hang on for some more minutes. We're just trying to get through this in a sense that we have to do this problem. Try to do it. Let's see. We have not yet used the fact that EF is parallel to BC. Okay, so maybe if I use that, I can say AF by FG, no, AF by FC, I can say, is equal to AE by EB. So that I've just used that EF is parallel. This is equal to EH by HP also. So it's equal to EH by HP, that BD by DC is equal to EH. Oh, no, sorry, it's not equal to EH by HC. I'm sorry. In fact, that's how we will do it. So what is BD by DC? If we look at this region, this part, anyone? No, you're making the same mistake that I made. No, BD by DC. Pragadish, can you say? So HT, so you see HT is parallel to EC. Okay. So you can draw this separately if you need to. And then we have the B, E, H, C, and so on, right? So what can you say? If I have BD by DC, and that's equal to what? Like this EH and HE are there.
Okay, so if BD equals DC, then BH should equal HE.
Yes, if it's equal, but even if it's not equal, the ratio is the same.
Yeah.
Is that right? Yeah, this is just parallel lines create the same ratio, right? So BD by DC will be same as BH by HE. Okay. There is a twist going on this in the sense that you try to see this. And this is really what gives us 1, like A into A is 1 means that A is 1. Something like that, it's kind of happening. You'll see. So when we looked at BD by DC on the side of AC, on this side, right? Then we saw that BD by DC is equal to FG by GC, right? So FG came first and then GC down. But on this side, when we did BD by DC, it is BH by HE. It's kind of the opposite. Yeah. Can you make that more precise? Yes. Yeah, if you rotate it there, right. Yes, it's something like that. Yeah, that's a good way to see it. Right. But how can we use it now?
I don't understand what
That's a little vague. That's a vague idea. So it's fine. That is not important. And that's not. I mean, even I cannot make it precise right now. Yeah. Okay. Yeah. That idea, Ishana, is not. Is it pretty precise? No, right? It's a little. Yeah. It's like a twist. So I don't even know how to put it. Like, see, it's not really a reflection, but it is. Wait, I think we can make it precise, but yeah, so it is like if we fix C and maybe about some line like this, we kind of reflect the figure, then this B kind of goes to F, right? Or something like that. Yeah. And the E kind of, yeah, where does the E go? I don't even want to know what, and leave that. That's beyond what we know. We need to know now. So leave it. But you can, what I'm saying is that this FG by GC is not equal to HE by HB, right? It is equal to HB by HE. This is the twist, kind of. Okay, Pragadish? Okay, just this part, right? As FG by GC is not equal to EH by HB, it's the opposite of it. Like the ratio is not running in the same way like this by this and this by this. No, it becomes the opposite. And that's happening by the virtue of what by our observations, right? But I just wanted to see that in one shot, but that seems a little tricky. Well, it's not really tricky. I mean, you could also kind of see it. You could, I don't know, you have to think rather than saying. Just think about the rest of the problem. I'll just think of a way to say this. Yes, so it is like this, you see. If you take this point O, if you fix that point O, right, and if it's kind of like you have this point E, H, and B, and I don't know if it's completely correct, but if you take this point E and you take the perspective with respect to O, so it's kind of you join O and then you extend it, it goes to C, right? But if you kind of, it's kind of like reflecting it about the point O. Okay, you take B and you again pass it through O and you extend it this side. The B goes to F. The figure kind of flips. Okay, the H doesn't go anywhere. The H goes to G only. So the E goes to C. The role of E and E switches, right? And the role of B is taken by the role of F, and that's why it's kind of a flip. Okay, that's just roughly what I'm saying. Roughly. But that's not important to do the problem, maybe. So let's see. Now it is not very difficult. If you just combine this, calculations, combine this with AF by FC is equal to AE by EB. No, AB and AC will not be equal. If you can prove that, then something is wrong. Either your proof is wrong or what we have done is wrong. Right? AB cannot be equal to AC in general. It's just a general triangle, right? So I don't know. You can try to take this maybe as X, and this one as Y, and this one as Z, right? And with that, we can try to find the rest of the numbers. So this one will become, yeah. No, no, no. Because E and F can be very low. They can be very close to BC. So you cannot really say that. Okay. So now, well, I don't know. It should not be difficult. So let's see. So let's just introduce another variable. Let's call this AFSW. Then the FC will become YZ. So I'm just doing the calculations because you see we have used all the facts from the picture, kind of, right? There may be a better way to do this, and there are, but we are just kind of doing it. Then we know FC. Yeah, and now see if we just do some calculations. You see, you have to use this now. This we have not yet used, right? So just see, try to use this FG by GC. So you can take FG by GC. So you can take FG as another. You just take the other variables. Eventually, they will all simplify. Okay, you don't have to solve equations and all. Just writing it. FG is U by V is equal to Z by Y. Okay, you have this another one. So you have to kind of use this and so what is FC here? FC is U plus V. Is that right? Yeah. So you have to use these things. So how would you use them? YZ. Yeah, I think my mind has stopped working a little bit. I should keep going. Oh yeah, it's very late. So these are the ideas. Okay, then try to complete this. So we have used all the facts. Now you should get Y equal to Z from these things. So just try it, okay? And we will pick this up next time. Y equal to, but this was not so messy. I had done it once with this simple kind of method long back. So yeah, 1 minute. Just 1 second. Okay, just think about it. Okay, I think it's a little, we've gone a little over time. So we'll just. Or does it? Okay. Okay. So we'll take a look at it next time. Okay. Or you can just try to think about this. Because it may not be so simple. So I don't know. Here you will have another point X. You can try to use this maybe that AE by EB is equal to AX by XD also. Because this AD line is a common line. So that maybe you can use. I think that will help. Yeah, you see, this line AD is going to help you to combine the things without using variables. Just think. Okay. So I had given some problems last class, which I think Pragdish was not there in, but I will share it with you also. And I'm not giving a new problems this time. Okay. Just, okay, I already gave a problem. So try that earlier. And this one also you can try. And yeah, other problems I'll share with you. And then we'll meet on Friday. Okay. Yeah, I'll try to end on time usually. No problem. Okay, thanks.